Okay guys, so here's the situation now, okay? 4 feet of wire are going to be used to make a square and a circle, okay? So they're going to put a square here with a wire. Man, I always make this mistake. They're going to put the square here with a wire, plus this, plus that, plus that. And they're going to get more wire and do this, okay? Now, this perimeter here plus this circumference here have to be maximum 4 feet because you only have 4 feet of wire. So they got to sum to maximum 4 feet. Okay, so what's going to be one of the formulas? Well, 4 feet of the wire has to be equal to 4x, okay, which is 4 times the side of the square here, plus the circumference, which is 2 pi r. Okay, from here you can see that the domain is this for x. How do I know that? Well, x can be 0, okay? Because there's something else too. See, the x is the amount of wire that's going to be used in the square. Now, if 0 is used in the square, you're going to use the whole thing for the circle because you want to maximize the area, okay? That's the problem. You have 4 feet of wire and you have to make a square and or a circle. So maybe you can only make a square, maybe you can only make a circle, maybe you have to make the square and the circle. And if you do the square and the circle, how much of the wire you're going to reserve for the square and how much of the wire you're going to reserve for the circle. So you have 4 feet of wire, so it's going to be 4x plus 2 pi. Why 4x? Because we got 1x plus 2x plus 3x plus 4x, okay? And now plus 2 pi r. Why? Because that's the formula of the circumference according to the radius of the circle. Okay? Now why does x have to be 0 to 1? Because if x is 0, then you're not going to have a square, you're just going to have a circle. If x is 1, okay, then you're not going to have a circle because you have 4 feet of wire. So if x is 1 here, this is going to be 4 times 1, which is 4. Okay, which is 4, and then this has to be 0, because if this is not 0, let's just say that you put an x equals 2. If you put an x equals 2, this equation becomes 4 equals 4 times 2, 8, okay, plus 2 pi r, so this 8 goes over there, and you say that 2 pi r equals negative 4. That means you're going to have a negative radius. You can't have a negative radius, so you know that the wire used for the square has to be from 0 all the way to 1, not more than that, okay? I mean 1, the value of x. The value of x can go from 0 to 1, okay? And what is the area? The total area is going to be x squared, which is the area of the square, plus pi r squared, which is the area of the circle. So what we have to do is to have just one independent variable for the area. We're going to have only one independent variable for the area and derive this area with respect to this independent variable, okay, to make it 0. And then you have also to test the endpoints. You have to test the endpoints where the x is going to be 0. No, you got to test in the final solution when dA dx is 0, like this, dA dx is 0, you're going to find an x here that makes this happen, and you got to test this x in the final solution, and then you have to test the endpoints here, putting a 0 for x and then putting a 1 for x to see which one is going to win, which one is going to increase the area. You want the largest possible area. So what is x? Okay, using this formula here, first I'm going to divide everything by 2, so you got 2 equals 2x plus pi r. Okay, that means that x equals 2 minus pi r divided by 2. Yeah, I can also say 1 minus pi r divided by 2. Yeah, I can do that. Let me think. Yeah, I'm gonna leave it like this. So this is x, okay? So I just want to make sure that I'm not going too fast in here, okay? So x is going to 2 minus pi r divided by 2. and I'm going to replace that in the area. So area equals this, right? Which is going to be 4 minus 4 pi r plus pi squared r squared divided by 4. Yeah, plus pi r squared. Extending here, you got this. Okay. Now let me think. Okay. Now, oh man, I did something stupid here. I can do that because now I can differentiate with respect to r. Yeah, let's see if this works. That's not the way the book does, you know. I should have isolated r, but I isolated x, so I made a as a function of r. Yeah. So what I have to do now is dA dr, because yeah, okay. So you get a 1/4 in here, so I'm gonna put 1/4. Okay, I'm differentiating this with respect to r. So this is an independent term. It doesn't have any r. Forget about it. So this is gonna be 1/4 times what? You got a minus 4 pi, okay, plus 2 pi squared r. Guys, I don't know if this is gonna work. No, this is not gonna work because I have a domain for x. I don't have a domain for r. So this is not gonna work. It'll find the solution if you get into the right domain, but no. So what I'm gonna do is isolate the r. Okay, so r equals 4 minus 4x divided by 2 pi. 4 minus 4x divided by 2 pi. So you forget about this. This is a 2 and this is a 2. Okay, it's going to be 2 minus 2x divided by pi. And then you multiply it, put it over here. So a equals x squared plus pi times this squared. Well, okay. So pi times this stuff squared. It'll be 4 minus 8x plus 4x squared divided by pi squared. Okay, get this pi out and get this thing out here. And now what do you have? You have x squared plus 4x squared. So area equals 5x squared minus 8x plus 4. Yeah, actually you can't do that. I forgot to take the minimum common denominator. I gotta put a pi here because you see this is a fraction, this is not a fraction. So in order to extend here, I have to put a pi here. Alright? So in x squared, you got an x squared here, but what is the coefficient? It's going to be 4 plus pi. 4 plus pi. Yeah. Minus 8x plus 4 divided by pi. Okay. Let's see if this is the thing for real. I just want to make sure here, guys, that I'm not 2 minus 2x divided by pi. Okay. This must be right. X squared plus pi times 4 minus 8x plus 4x squared divided by pi squared. Go to pi here. And then x squared is going to be pi 4 plus pi minus 8x plus 4 divided by pi. Okay, seems that I didn't make any mistakes. I'm gonna move this here, like that, like that. So now I gotta differentiate dA with respect to x. This equals, so 1 divided by pi, I'm taking this pi out, okay? So what do you have? You have 2, yeah. You have 2 times this, so it's gonna be, yeah. Oh well. 4 plus pi times 2x minus 8, and that 4 just becomes a 0, okay? So all of this is dividing pi. So what do you have here? This equals, yeah, and there's something else, guys. You see, it's 1 divided by pi, okay, and it's actually dividing the whole thing. And this needs to be equal to 0, okay? But right now, I'm just gonna do something here. So this is gonna be 8, yeah, 8x, right? I just didn't want that to happen, but there's nothing I can do. Plus 2 pi x minus 8 divided by pi has to be equal to 0. So 8x plus 2 pi x minus 8, okay. So cross multiplying, you can get rid of that. Dividing everything by 2, you got a 4 here. This goes away. Here you have a 4, okay. So you gotta isolate the x. So you still have 4, okay, plus pi equals minus 4, so equals 4. X equals 4 divided by 4 plus pi. Just want to see something here. I pass this dividing thing here. There. Okay, so x equals this. The approximation that the book uses for this is 0.56. So x equals 0.56. Does that mean that 0.56 you have to put it over here? No. Now you have to test it, right? Which one is going to give you the largest area? So erase this stuff. So we know that x 0. Okay, so 0.56. So you have 3 x's here that you have to test, 0, 1, and 0.56. So let's see. If you put 0, let me just think here. Man, this is gonna be long. Yeah, this is gonna be a long thing. Okay. Because if you put in there, yeah, this is gonna be a long exercise. So we gotta replace x equals 0. Let's think about that, okay? If that's the case, then you have 4 equals 4 times 0 is 0, 2 pi r. That means that r equals 4 divided by 2. Yeah, it's going to be just 2 divided by pi. Okay? Now, if this is what you have, what's going to be the area? Right, I made a mistake that I erased the area here. Let me see if I can get the thing back. You see, what I should have done, I should have never gotten rid of that. Let me just go back. See, this is the area here. So I'm not going to erase all this. I'm just going to erase from here down. It'll be easier. Okay. Now you have 0.56. So you plug 0 here, and then you plug 1 here, and then you plug 0.56 here, and you find out which one gives you the largest area. Okay? So let's just say that 0, for example, for x equals 0, what's going to be the area? Okay? So this is gone, 4 divided by pi. So let's see here. Yeah. I'm going to use 3.14. So 3.14. Going to be 1.2739. Yeah. The area is going to be 1.2739 approximately. Okay. What about when x equals 0.56? So the x equals 0.56, the area is going to be equal to what? So let's see here. 0.56 times 0.56 equals that. Okay. Times that'll be 7.14. Okay. So we have 2.2391 approximately, okay, for this term. And then we have minus x, okay, well, 8x. So 0.56 times 8, 4.48. So minus 4.48 plus 4 minus 0.48. Okay. So 2.23 minus 91 minus 0.48 equals 1.70. Oh man. 0.7591. Okay. So this is for this one. Okay. So I see that if I use an area, an x of 0.56, it's going to be a larger area than than just 0. Okay. Which is really strange, because it shouldn't be like this. Oh no, I made a mistake. I knew it. I knew something was wrong. This one here for 0.56, it's not that. It's 9847. Okay. Minus 8 times 0.56. So this is going to be 0.48. And here equals 9. I'd say that's 9.9799. Okay. Yeah. So you can see that if I use x equals 0, that means that I don't have a square at all. I'm going to have 1.27 in area, which is larger than if I have a square of 0.56. Yeah, with a side of 0.56. What about 1? Okay, so now we got to do x equals 1 and see what the area is going to be. So 1 squared I'm going to put 1 here in this formula. So 1 squared equals 1. So 4.4 plus 3.14, it's 7.14. Okay. Minus 8 plus 4 is minus 4. So this equals 3.14. Something's wrong again. I'm going nuts here, guys. Yeah. I'm just forgetting about one thing. You still gotta divide the whole thing by pi. Yeah. 0.004 divided by pi. I already got this. Okay. So this one here, I still have to divide it. Okay. So it's gonna be 0.9799 divided by 3.14. Which is actually going to be, I think it's going nuts, dude. Dividing this by pi, because I forgot to divide by this pi here. In this one, I didn't. Okay, when you plug 0 here, you got 0 here, 0. 4 divided by pi is equal to this. Now, the second one here, I made, this is the calculation of the numerator, and I have to divide by this pi. So dividing by this pi, I actually got 0.312, and I'm just going to put a 1 here because this is an approximation. Okay. Now, the numerator, if this is 1, so it's going to be 4 plus 3.14, that's 7.14. Okay. Minus 8, because x equals 1, minus 8 plus 4 is minus 4. So it's 7.14 minus 4 is 3.14. But you also have to divide this by pi. Okay? Now you gotta divide the end here by pi, which is 3.14. I'm just approximating. So the area is gonna be equal to 1. So you can see that the largest area, 1 here, and in here 0.3121, and see here 1.27. The largest area is when I dedicate nothing for the x. If nothing is for the x, look at the x in here. That's for the wire. That's the wire for the square. So nothing on the wire. None of the wire will go to the square. All the wire, or all the 4 feet will go to the circle. And that's how you have the largest area of 1.2739 approximately. That'll be it for me, guys. I'm really sleepy. I don't know if I'm kind of dizzy. I just went through surgery in my eye about a month ago, and sometimes I get dizzy and tired, and I just don't know what's happening to me. That's why I'm making so many mistakes. So that's it.